So today we are going over the applications of proportions Unit 5 test review. These are the things that you need to be able to do before you take your test. You need to be able to write ratios, find unit rates, solve problems with proportions, use similar figures to find missing side lengths, and write a scale factor for a given dilation. So let's go ahead and jump right into the review. It says, in a class, there were 24 boys and 18 girls. Write the ratio of boys to girls in simplest form. All right, so when we look at this, it says boys to girls. So we know we want boys first, and there are 24 boys. And then you can write ratios three different ways. First, I'm just going to go ahead and put the word to in there, and then we want girls, and there are 18 girls. That's one way to write the ratio. You could also write it with a semicolon, or you could write it as a fraction. Those are the three different ways to write the ratio. But in this case, it wants it in simplest form. So we have to simplify this. Now, for some of you, you might be able to look at it and say, oh, I can divide each of those by 6. For some of you, you're not going to be able to look at that and figure it out. So I want to show you that you can always go to Desmos and you can type it in. Like I like to type it in as a fraction to reduce it. So let me show you that. If I type in 24 divided by 18. First, it's going to give me a decimal, but I don't want the decimal. I want the reduced fraction. So then you go over here and you hit this blue fraction button, and that gives you the most reduced fraction. So the most reduced fraction is 4/3. So I'm just going to rewrite this as 4/3. So that means that it could be written a lot of different ways in multiple choice. It could be written as 4/2/3, or it could be written as 4/3, or 4/3. So that's our original ratios, and then we reduced it in Desmos, and those are our simplest form ratios. We want to solve this proportion. So if we have a proportion with an equal sign in the middle, well, of course it will have an equal sign in the middle. That's what it means to be a proportion. We are going to cross multiply. And I always like my x to be on the left-hand side, so I usually pick whatever side has x and multiply that first. So if I cross multiply here, I would have 2 times x. And if I cross multiply this way, I would have 5 times 8. And you can do that in your brain or your calculator. I'm going to go ahead and do 5 times 8 over here. That equals 40. So I get 2x equals 40. Remember, anytime you're solving an equation, you want to get x by itself. Right now it says 2 times x. The opposite of multiplying is dividing. So I'm going to divide each side by 2 so that x is by itself. And 40 divided by 2 is 20. Of course, you can type that in your calculator if you want to double check yourself. Find the unit rate for traveling 414 miles in 9 hours. All right, when we see this word unit rate, we want to know what it is per one thing. In this case, we're dealing with hours, so we want to know how far we go in 1 hour. We just want 1 unit. All right, so we would take our 414 miles and we would divide it by 9 hours to see how many we go in 1 hour. So let's do that. 414 divided by 9. So that means we go 46 miles per hour. In each hour, we go 46 miles. So let me go back here. So that's our unit rate as we go 46 miles per hour. Let's look at this next one. In 7 months, 10.5 gallons were used. Find the unit rate. So again, we just want to do 1. A unit rate means 1. So in this case, we want to know how much per 1 gallon. So we're going to take our total gallons and we're going to divide it. Oh, wait. Sorry, I told you wrong. Okay, so I just made a mistake. We're not trying to deal with our unit rate is, oh, why is that not an eraser? Our unit rate, we're not looking for 1 gallon. We're looking for how much we use in 1 month. Because we're dealing with 7 months here, and we want to know how many we use in 1 month, how many gallons we use per month. So our unit rate, we're looking for 1 month. So we're going to take our gallons and we're going to divide it by our months. We can go to our calculator and do 10.5 divided by 7. And that's 1.5. So this tells us that we use 1.5 gallons per month. All right, the polygons are similar. Find the value of x. So when we see this word similar, similar means same shape, different size. But it also tells us more specifically that all the corresponding angles have to be congruent and all the corresponding sides have to be proportional. So that's what we're going to use when we see the word similar. We need to know that the corresponding sides are proportional. So let's look at that. When we say corresponding sides, we mean the sides that go together. So like here, if we look at AD, that corresponds to JM. And then if we look at DC, that one corresponds to ML. DC wouldn't correspond to KL. Do you see how those aren't the same? You want the sides that go together. And then you don't have to know the rest of these, but AB corresponds to JK and BC corresponds to KL. So we found the corresponding sides, but because they're similar, the corresponding sides have to be proportional. So we can set up proportions to find our missing value. Now I usually like to make my first fraction with whatever my letter is. So I'm going to make my first fraction x over 40. And it doesn't matter if that's your first fraction or not. All that matters is that your second fraction has to match it. So since I did x on the top, I need to make sure that I do 3 on the top of the other one. And since I did 40, the red on the bottom, I need to make sure that I do 12 on the bottom over here. And then once you have it set up, you can cross multiply. 12 times x is 12x. 40 times 3 is 120. And then we're solving for x, we would divide each side by 12, and x would equal 10. Now, of course, you can do all of this in your calculator. You can do 40 times 3 in your calculator, and then you can divide it by 12. So you don't have to be able to do that in your head, but you do have to be able to set up your proportion and solve it. Okay, how tall is the tree? Now, in this case, it doesn't tell you that these are similar triangles, but if we look, we can tell that they're similar because they have, their angles are congruent and their corresponding sides are going to be proportional. So let's go ahead and check, let's go ahead and set up a proportion. So if I'm going to use, we want to find the height of the tree, and I'm just going to go ahead and label which side and the other triangle corresponds to that. Since that's my vertical distance there, this one's going to correspond to it. And then I also know this distance, and that corresponds to this distance. So when I set up my fraction, remember, I like my first fraction to have the letter in it. So I'm going to set up my first one as h over 24. And then when I go to set up my second fraction, I just have to make sure that I get the corresponding sides matched up. So since I did h on the top, I need to make sure I do 3 on the top. And since I did 24 on the bottom, I need to make sure I do 6 on the bottom. And then we can solve our proportion by cross multiplying. H times 6 is 6h. 24 times 3, I don't really know it. 72 maybe? I don't know. 24 times 3 is 72. And then we got to finish by solving for h. Since we have 6 times h, we'll do the opposite, which is to divide. And then 72 divided by 6 is 12. So the height of the tree is 12 feet. The sides of the square are increased by a scale factor of 5. Now, remember, the scale factor means you're making it 5 times bigger. The perimeter of the small square is 8. What is the perimeter of the large square? So you have to also kind of remember, well, in a square, all 4 of your side lengths are the same. And when you do perimeter, you add up all the side lengths. So if I have to add up 4 sides and get it to equal 8, then I know each of them has to be 2, because 2 plus 2 plus 2 plus 2 equals 8. So in my small square, I know that each side is 2, and my perimeter is 8. But now I need to do a scale factor, and I need to make it 5 times bigger. So when I do my new square, each of these sides need to be 5 times bigger. So 2 times 5 is 10, which means each of these sides is 10, which means if I find the perimeter, I would add up all those sides, and the perimeter of my bigger figure would be 40. Now there is kind of a shortcut here. You could take your perimeter of 8 and you could multiply it by the scale factor. Now this only works in perimeter. We're going to look at an area problem in just a minute, and you can't just multiply it like that. This only works for perimeter. So let's look at the area. A right triangle has an area of 15 meters squared. So we have a right triangle. I don't really have to draw it, but the area is 15 meters squared. The dimensions are increased by a scale factor of 4. So we are making it 4 times bigger. What is the area of the new triangle? So in this case, we're dealing with area, which is meters squared. So when we deal with our scale factor, if we want to take the shortcut, like on this last problem, we were just dealing with perimeter. So it was just 2 meters. Each side was just 2 meters. So I took my scale factor, 5 to the first power, and I multiplied it by my perimeter. If I want to take the shortcut here, I could take my area, which is 15 meters squared, and I could multiply it by the scale factor. But because we're dealing with meters squared, the scale factor has to also be squared. So you could do 4 squared is 16, and 15 times 16. Well, here, let's just type it in. 15 times 4 squared. So my new area would be 240. You cannot, 40 meters squared. You cannot just say 15 times 4 because we're not just dealing with meters here, we're dealing with meters squared. So it's really important that you look at your units. If your units are squared, you need to make sure that you square your scale factor before you take the multiplying shortcut. All right, what is the scale factor? We're going to look at this both ways. The way that this problem is originally written says it starts with the red triangle and it ends with the blue triangle. And the reason I know that is because if you look at the letters, this is labeled as B and this is labeled as B prime, or B with a tick mark. The prime symbol, that little tick mark, means that that's the second thing that you've drawn, or that's the one that's been changed. So if we look from red to blue, this is getting bigger. So I know that my scale factor has to be greater than 1. And I'm just going to pick any point. I'm going to just look at A's, I guess. From here, from 2 to get to the x value of this one, it's 4. So I have to ask myself, how did I go from 2 to 4? Well, you might say, oh, you add 2, or you might say, oh, you multiply by 2. Well, let's look for the y values. We go from 1 to 2. So if you were trying to add, you would add 1. You can't add for scale factors, but you can still multiply by 2. If you multiply each of these by 2, you'd get your new points. Now let's double check that with B. If I do -1 times 2, I get -2. And if I do 3 times 2, I get 6. So that is correct. So my scale factor is 2 because we're getting 2 times bigger. And that's to go from red to blue. If you wanted to go in reverse, which you don't want to do this on the test unless it tells you to, but if you were going from blue to red, you can see that you're getting smaller, which means your scale factor has to be between 0 and 1, or it has to be a fraction. So if you're going from blue to red, it's becoming half of its original size. So that would be the scale factor if you were going from blue to red. So just be really careful that you know which direction you're going in. If it's getting bigger, your scale factor has to be greater than 1. If it's getting smaller, it has to be between 0 and 1. All right, we're going to finish the rest of this review on the next video.